All right, so yesterday we long division. Today we're going to do synthetic division. So we did this in Algebra 2. And the problem is in Algebra 2 we just did it. And we didn't really explain why we did it. But the reason we do long division and synthetic division is because you can factor polynomials. So here's the theorems that tell us why we do this. So the first one is the remainder theorem. If a polynomial is divided by x minus c, the remainder is written this way, and that's the remainder. This allows you to evaluate f of x for x equals c by dividing x minus c using synthetic division. This process is called synthetic substitution. So that's a nice definition, right? But you have no idea what that means, right? So here's what it means. So all of these words mean when you divide, if you get a remainder, that's a point on the polynomial. So if I divide that big long polynomial by x plus 2 and I get a remainder, that point is on the polynomial. Okay? And so the next one is then the factor theorem. And what the factor theorem tells me, if the remainder is 0, it's a factor. So if f of c equals 0, this means you can use synthetic division to check if they're linear binomials. And that means they're factors of the polynomial if the remainder is 0. So if there's a remainder, it's a point. If it's 0, it's a factor, which means it's a root or an x-intercept. Okay? So let's just go over how to do synthetic division. So first of all, this, x plus 5, x plus 5, it is a factor. All right? When it's written like this is a factor. I want to know, is x plus 5 a factor of this? What's the root? If it's x plus 5 is the factor, what's the root? That's right. X plus 5 equals 0. This is the root. And that's what you want to test. So in synthetic division, I'm testing the root. So I put the -5 right there. That's the factor, and I want to test the root. So right here, then what I want to do is I'm going to take all of the coefficients, and I'm going to write them down. So I get 1, 1, -17, and 15. And leave a little room and draw a line. So I'm always going to start by bringing down the first number. And then I'm going to multiply. -5 times 1 is -5. And from here, I'm going to add. So that gives me -4. -5 times -4 gives me +20, and I'm going to add and get 3. -5 times 3. This is your remainder. The last one is your remainder. And I'm going to put a box around it so you know it's the remainder. This time it's 0, so that tells me it tells me it's a factor. F of -5 is 0, and so it is a root, and x plus 5 is a factor. Because I know everything. Now, it's a factor. So I got 0. It's a factor. This, what's left, is called the suppressed equation. And if I divided this by an x already, that means that my answer has 1 less x, right? Because x cubed divided by x would give me x squared. So this would start with x squared. So whatever this one is, the suppressed equation is 1 less. And I would write that as x squared minus 4x plus 3. So I'm going to tell you what this is. So this is the polynomial, and I divided by x plus 5. And if I long divide across the top, this is what I would get on the top. Correct. So if I divided, this is what's left over. It's called the suppressed equation because I took part of it out. Okay? So I just want everybody to take a really quick look, though. X squared minus 4x plus 3. Does that factor? No. It does. It would be x minus 3, x minus 1. And that would give you all the factors. Okay? That's it. That's all I want. I want to know if it's a factor or not a factor. Yep. Number 2. I don't think I can go any slower. So first of all, what's missing? The squared and the x, right? So this is my factor. So what's the root? 2. So the 2 goes here. And when I fill this in, I have to fill in for what's missing. So I get a 1, a 1, a 0, 0, and negative 1. Bring down the 1. 1 times 2 is 2. When I add, I get 3. 2 times 3 is 6. Add, I get 6. 12. So write down the suppressed equation. Oh, positive. It's positive. I was trying to hurry. Leave me alone. Honestly, you're really not. So this is the suppressed. First of all, is that a factor? Yes or no? No. It's not a factor because of 23. But what that tells me is f of 2 equals 23. So that point is on the polynomial. And this is how I'm going to write the answer here. So if you wrote the suppressed equation, you got x third plus 3x to the second plus 6x plus 12 plus 23. And what does 23 go over? X minus 2. It goes over the factor, just like yesterday.
Plus x minus 2?
Yes.
So that's the answer, right?
Right here, yes.
So if it's not a factor, then you write the suppressed equation?
Yes, yes. Next. I have what's the root? Negative 5. And I'm going to have 1, 0, negative 30, and 0. Bring down the 1. Negative 5. So f of negative 5 equals 25. I know that point is on there. My suppressed equation is going to be x squared minus 5x minus 5 plus 25 over x plus 5.
I always know how to do it, but what if I get a class that goes at my
Okay, what's the root?
Negative 1.
Negative 1. So I'm going to have 1, 7, negative 1, negative 7. Bring down the 1. So f of negative 1 equals 0. It is a root, and so that's what's left.
So for the answer, you want both of those as f of whatever, and then the x squared plus 6x.
So on the root one, you have to tell me it's a factor, right? We have, this is the suppressed equation, this is the factor. If there's a remainder, we just write it with the suppressed equation and the remainder.
You still want that f of whatever?
Well, I want you to write it so you remember it, because we're going to use it.
X plus 1 of the factors of the answer.
This is the answer, Isaac.